Hey, good evening, guys. Hope you are doing well. So today I'm just going to show you a demo of how will you receive the DNA sequencing results from the company. Okay. So you send the samples to a company. They will do all these three steps, main steps like DNA extraction, PCR, and DNA sequencing. They will email you the results. I'm showing you a demo of how the results looks like. Okay. So whichever the company is doing this, they will be sending you the details of the how they did it, and here will be the DNA sequences. Okay. Apart from this, you will be receiving something like this. Okay. Um, the notepad files containing DNA sequences. All right. So you will have a forward sequence and you will have a reverse sequence extracted out of it, and finally the compiled sequences of forward and reverse. I will show you how to do the analysis using this. So copy this sequence. We'll do the blast analysis. Okay. So in the blast, standard DNA sequences can be selected. Okay. And paste the sequence. Go for blast. So what is happening in basic alignment search tool is your sequences is actually aligned with the references sequences, and the results are calculated. Okay. So whichever sequences is closely matching, or whichever sequence our sequence is closely resemble to, they will be taken as the result and it will be displayed. When they display the result, it will be displayed like this, right? Okay. So now I know my strain is 100% similarity to Micrococcus luteus. So if I see the results down, all are from Micrococcus luteus. So with the confidence, I can say it is Micrococcus luteus. So what is this phylogenetic analysis does? Okay. For phylogeny, I would suggest if you want to include closely resembled species, different species of same genera. So during blast analysis, instead of just selecting for standard database, go for rRNA database. What this will do is this will give you the sequences that are related to the no, the same species will not be repeated in the results. If you see first two sequences, 99.62% similar to Micrococcus luteus, then there are different species of Micrococcus. Okay, so this is ideal for phylogenetic tree construction, and moreover, all are from authentic species. Means species they are from type species, meaning they are the examples or they are the authority of that particular species. For example, so here, Glutamibacter mysurans, whenever the accession number starts with NR, you will say that this is the type species sequence of Glutamibacter mysurans. Okay. So all those type species are displayed here. So if I want to go for phylogenetic tree construction, better extract sequence from type species and compare with your species. Okay. So for that, what I will do, I will consider this. Deselect all. Then I will select the sequence only I want. If I want to have a beautiful tree, I would say just select some distant numbers other than 98%. Okay. So flavors one, two, three. Okay. We don't have much microcontrollers. Let's see. Whenever we go down, the percentage of similarity is also increasing. For okay, no TS is okay. We take some citrococus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, at least 10 sequences is essential for constructing the phylogenetic tree. So download complete sequences. So after completing, I have all the sequences downloaded here. Okay, it is very much essential to include my sequence also that I will be using for phylogenetic tree construction. So say I would write my sequence. Okay. So like I described in previous videos, you should be introducing underscores. So what I'm doing here is actually introducing underscore. There should not be any empty spaces left between the accession numbers or between the genus and species name so that the entire segment will be taken. And most importantly, one common mistake everyone does is make sure you are not downloading the full complete genome of an organism. You are downloading only 16S RNA. How do I know it is a 16S RNA or complete genome? Check the accession length. Check here. Oh, I'm sorry, here. The percentage of variety. Everything is around 1500, right? So then I guess here there is no complete genome. Sometimes I have seen 55 lakh something base pairs are presented. So those are definitely complete genome. We should not be downloading. And one more important discipline we need to have in bioinformatics analysis is whenever you are starting an analysis, start a separate folder maybe. Okay. So here it is seq dump 28. Better you save the files inside your folder. Okay. So here I have this sequence. So I will close this. I better have this sequence in a separate folder. Say my tree. Okay. So now cluster X. Locate your sequence. So I got all my sequence here. I will go for see the folder. Whenever the alignment is done, the separate ALN file is actually created by default inside the folder, which will act as the input file for mega analysis. Okay. So analysis is done. I want to know what is the star mark indicates that you have a same position. Say for example, if there is a star mark here, or this says at the position 50, all the base pairs are same. That's why it is indicated by star mark. So another common question I had is, can we delete this gap? Yes, you can. Whenever you have a suspicion that, see for example, in this sequence, Citrococcus nitrophilus, nitrophenolics. See here, the thymine might be a machine error. So, it is just one thymine that's been inserted. Could be a machine error. This gap can be deleted. There are other instances where we should not delete the gap. Okay. So anyway, this sequence is our sequence is actually short. So after this region, it has to be deleted, which cannot be done in the cluster. It should be done in the mega. So I'm closing this. I know here is an ALN file that is an in which was not there before cluster analysis. I just got this file after cluster analysis. So that's my ALN file is an input file. So I'm opening mega build alignment. Yes, I'm building the. Now, for many people, it's very easy if you can see both your ALN file and Mega like this. So that when I click this, it may go. Okay. Just drop it here. The current session is empty, so nothing to save. So what I will do, I will select this and cutting this. Okay. I don't need these gaps because there are only few sequences among 10 has these insertions. So I will cut these gaps. Making sure no more gaps are there. So again, I will do one more alignment to see whether new gaps are introduced. If I have trimmed both gaps in front of the first star and after the last star. So again, I will check whether any gaps are introduced. These gaps are fine, okay, because among 10 sequences, these gaps, among 10 sequences, almost 8 have the insertion, only 2 are missing. So democratically speaking, you can add up those gaps. So I'm going through this and I'm not seeing any gaps, so the alignment is ready. I would say this can also make a pairwise data file. So better you save as this session, okay, alignment session in my tree sequence file. Okay, so my tree alignment session is saved. From here, go to phylogenetic analysis. It's not a protein coding, it's a 6-ness RNA. Minimize the window. So this is yes, default parameters. Okay, then I'll click OK. And that's it. I have my phylogenetic tree. Now you know the issues here. They may not accept every uh, sequence length. So what I should be doing, I should check the names of the tree. So luteus is fine. Okay, my sequence is cladded with Micrococcus luteus. This is fine. But endophyticus. So those words are missing. See, endo. At the end is insert phyticus. Usually what I will do, I will double click, I will click the end button so that the cursor is at last. Many times, if you just double click it, the entire text may be lost, okay, while entering it. So that Handaticus, Ticus, so end button, Cus. Okay. Lilac, okay, flavors. All right, Terius. Okay. Kohini. Okay. I will find Citrobacus nitronolicus. Okay. All right. So here's a tree. How to save the tree? We will go for images. Okay. Before that, I need to indicate where is my sequence in the tree. So um, go here. I will introduce some symbol so that easily it is recognizable. Okay. So it is fine. So in the tree, I have indicated where is my sequence. So image, PNG file. Connect. Okay. So now if you open your folder, you'll end up seeing your tree file. Okay. Now we'll see about pairwise distance alignment. That's your tree file, right?